We start with a cubic Bezier curve. A cubic Bezier curve is typically defined as a curve represented by these 6 parametric equations. However, the meaning behind these equations may seem unclear at first glance. But there is a more organic way of understanding the cubic Bezier curve. Let's say we want to construct a cubic Bezier curve that starts and ends at these points. We'll need 2 additional points to define the shape of the curve. These 4 points together are called the control points. First, we connect the points together with a line. The first 3 equations tells us to move these 3 orange points across each line over a certain period of time, in this case, 1 second. We'll connect the orange points with line segments so that as the points move, so do the line segments. The next 2 equations tells us to move these 2 purple points across each of the orange line segments, once again over a period of 1 second. Like before, we connect the points with the line so that as it moves, so does the line. Finally, the last equation tells us to move this yellow dot across our last line segment over a period of 1 second. As we move all the points, the yellow dot follows a certain path. This path is a cubic Bezier curve. We can also combine the parametric equations to obtain this cubic polynomial, where C0, D0, E0, and C1 are the positions of each control point. This polynomial also describes our Bezier curve. Our algorithm can be summed up as follows. Connect the points with line segments, move new points across each line segment, and repeat the process with our new points and new line segments until we're left with only a single moving point. We can apply the same algorithm with any number of points as long as we have at least 2 points. With n control points, we get a Bezier curve of degree n minus 1. For example, using 4 points gives us a cubic Bezier curve, whereas using 3 points will give us a quadratic Bezier curve.